Ever wondered how Java abstraction makes your code more flexible and reusable? Well, you're about to find out. In the vast realm of software development, Java abstraction is a concept that cannot be overlooked. It's an essential part of the object-oriented programming, or OOP, paradigm. It's the process of hiding the implementation details from the user and only providing the functionality. Think of it like a car engine. You don't need to know the intricate details of how it works to drive a car, right? Similarly, in Java abstraction, the user doesn't need to know the background processing. This makes the code much more manageable, flexible, and reusable. It's like a secret recipe that makes your programming life a whole lot easier, and the best part is it's not as complicated as it sounds. Ready to dive deeper into the world of Java abstraction? Buckle up! Before we delve deeper, it's crucial to understand the basics of Java abstraction. Imagine you're building a house. You wouldn't start with the intricate details like what color to paint the walls or where to place the furniture. You'd begin with the blueprint, the fundamental structure that outlines the basic components of the house. This, in essence, is what abstraction is all about. It's a process of hiding the complexity and showing only the essential features, much like the blueprint of a house. Now let's relate this to Java. In the world of Java, abstraction is mainly achieved through two mechanisms: abstract classes and interfaces. Both of these serve to provide a blueprint for other classes, outlining what methods they should have, without specifying how those methods should be implemented. An abstract class in Java is a class that cannot be instantiated. That means you can't create an object of an abstract class. It typically contains one or more abstract methods, which are declared but not implemented. The implementation part is left to the classes that inherit from the abstract class. On the other hand, an interface in Java is a completely abstract class that can only contain abstract methods. Unlike abstract classes, interfaces can't contain any implementation at all. It's like a contract, promising that the classes that implement the interface will provide certain functionality. In both cases, the goal is the same: to hide the complexity and expose only what's necessary. The beauty of abstraction is that it allows you to focus on what a thing does, not how it does it. This not only simplifies the coding process, but also makes the code more flexible and easier to modify or extend in the future. So let's think of Java abstraction as the architect of our coding world, providing us with the blueprints we need to construct our software houses. With the basics now clear, let's explore how Java implements abstraction. Abstract classes, one of Java's keys to abstraction, but how does it work? Let's dive into the world of Java and explore this intriguing concept. An abstract class in Java, as the name suggests, is something that is not concrete. It's like an incomplete blueprint that can't be instantiated on its own. Instead, it provides a foundation for other classes to build upon. One of the key features of an abstract class is that it can contain abstract methods. These are methods that are declared but not implemented in the abstract class. Sounds confusing? Think of it as a promise. When a class declares an abstract method, it's promising that any class that extends it will provide an implementation for that method. Now you might be wondering, why would anyone want to use an abstract class? Well, it's all about abstraction, the process of hiding complex details and showing only the necessary information. Abstract classes are a pivotal part of this. They let you define a common structure and behavior for related classes, making your code easier to understand and maintain. Let's illustrate this with a simple example. Imagine we're designing a program to model a zoo. We could create an abstract class called Animal, with abstract methods like eat and sleep. Then, we could have classes like Lion and Elephant that extend Animal and provide their own implementations for these methods. This way, we can use the abstract animal class to represent any animal in our zoo without worrying about the specifics. But what if we want to add a method that all animals share, like breathe? We can simply add a non-abstract method to our animal class, and every class that extends it will automatically have that method. This is another powerful feature of abstract classes in Java. They can contain both abstract and non-abstract methods. Abstract classes are cool, right? But there's more to Java abstraction: interfaces. So stick around as we continue to unravel the fascinating world of Java abstraction in the next scene. Interfaces in Java, another pillar of abstraction. Intrigued? You should be. Now let's delve into interfaces, a vital part of Java's abstraction mechanism. To put it simply, an interface in Java is a completely abstract class that can include abstract methods and constants. It allows you to define a contract for what classes should do without specifying how they should do it. A class implements an interface, thereby inheriting the abstract methods of the interface. Considering a real-world example, think of an interface as a blueprint for a building. The blueprint outlines what needs to be built but does not dictate the construction method. Similarly, an interface in Java outlines the methods but leaves the implementation to the classes. Let's say we have an interface named vehicle. This interface might have a method called speedup. Any class that implements the vehicle interface must provide an implementation for the speedup method. Here's a simple example. In this example, bike is a class that implements the vehicle interface. It provides its own implementation of the speedup method, dictated by the interface. Now, what makes interfaces so special in Java? The answer lies in the power of abstraction they provide. They allow unrelated classes to implement the same methods, enabling the programmer to use polymorphism to switch between different implementations at runtime. Furthermore, interfaces enable a form of multiple inheritance, as a class can implement multiple interfaces. This is a feature not directly available in Java, as a class can only extend one other class. Now you see how abstract classes and interfaces work together to achieve abstraction in Java. But how does this all come together? Time to see Java abstraction in action. Are you excited? You should be. Let's imagine we're building a game. The game has all sorts of characters like knights, wizards, and elves. In Java, we'd start by creating an abstract class for these characters. This class would define some common characteristics and behaviors that all game characters share. Things like hit points, attack power, and movement speed. But here's where the magic of abstraction comes in. We don't need to specify how each character attacks or moves. Instead, we create abstract methods for these behaviors, leaving the implementation details to the subclasses. This way, the knight, wizard, and elf classes can each define their own unique way of attacking and moving. Now let's say our game has a feature where characters can equip different types of weapons. In this case, we could create an interface called equipable. This interface would define the methods a class needs to have in order to equip a weapon, such as equip weapon and unequip weapon. Again, the beauty of abstraction shines through. We don't need to know how each character equips a weapon. The knight might simply grab a sword while the wizard conjures a staff from thin air. As long as they follow the equipable interface, they can do it their own way. So in our game, we've taken a complex system, a variety of characters with different behaviors and abilities, and simplified it using Java abstraction. We've created an abstract class to define common behaviors, and an interface to ensure certain classes can perform specific actions. And that's the power of Java abstraction. It allows us to focus on the big picture without getting bogged down in the specifics. It helps us manage complexity by breaking down systems into smaller, more manageable parts. That's Java abstraction for you, simplifying complex systems into manageable chunks. We've covered a lot today. Time to wrap up and revisit our key points. We embarked on a journey through the world of Java abstraction, a cornerstone concept in software development. We started by understanding the basics, learning how abstraction allows us to focus on what needs to be done, rather than how it's done, creating a simplified model of complex reality. We then delved into abstract classes, these unique entities that cannot be instantiated, but serve as a base for other classes, promoting code reusability and method overriding. We explored interfaces, the blueprint of a class, which pushes Java's abstraction to its peak, allowing multiple inheritance and providing total abstraction. These concepts of Java abstraction, abstract classes, and interfaces are the backbone of software development. They foster modularity, flexibility, and maintainability in code, making programming more efficient and manageable. Java abstraction, a powerful tool for any programmer. Keep exploring, keep coding, and see you in the next video.